We have a Singapore Math Olympiad problem. This is problem number 7, and a fellow by the name of Wei Tan worked a problem similar to this. And the actual problem was different than this, but this is just a problem that's very similar. Now, I think we have to assume that b is greater than 0 because we're going to end up using something where that's part of the result that we have to use. But in any event, the way this thing is set up, it begs for us to rearrange the factors to get it as the product of these two difference of two squares. Okay, and you can see that's very straightforward. And so we're given that this expression, which can be rewritten like this, has a minimum value of minus 64 squared. Okay. Now, notice here that there's a strong relationship between this statement and the maximum value. Notice that x squared minus 31 squared. And this is pretty easy to see, but I'll write it down anyway. X squared minus 31 squared, okay, is just equal to the negative of the expression above. In other words, this is straightforward right here. 31 squared minus x squared, right? And I need a minus sign in front of that. Okay, so we need a minus right out here. Okay, so you see that explains, so that's minus that. Minus this expression right here is certainly equal to that. Now, that explains how we can rewrite it like this and change the smallest value to the maximum value. And I hope that's clear. It's fairly straightforward right there, okay? So we get a maximum value of this expression. Okay, now we're still trying to find b, and so again, this is just a rewrite of what it means. If the maximum value of this expression is equal to 64 squared, that means for all values of x, the square root would have to be less than or equal to 64 if you just square root both sides, okay? And that's just a for all x sort of thing. We leave out those universal quantifiers quite a bit in mathematics, okay? Now, also, this next line requires some explanation. This very next line is a very well-known result called the arithmetic mean geometric mean inequality. And so, in general, if a and b are positive, it's not hard to show in the two-variable case that a plus b over 2, a plus b over 2, that's called the arithmetic mean, or just that good old-fashioned average, is always going to be greater than or equal to, and you can actually prove this in a couple of lines, the square root of a times b, okay? I probably should be using different letters, but I think you get the point here. A better choice, I mean, it's slightly confusing here, but this a and b aren't the same as the a and b up here. But anyway, the sum divided by 2 is greater than or equal to the square root of the product. And notice right here, when you sum these guys up, the x squareds cancel, okay? So that's how we end up with this statement right here, okay? Now, why is it equal to 64? Equality happens when a is equal to b, okay? So equality does occur when a is equal to b, and so this is what we end up with. And it's fairly straightforward to solve it from here. Notice this is the difference of two squares, so we can write down b plus 31. And again, yeah, I hope the choice of letters wasn't too confusing, but b plus 31. b plus 31 times b minus 31 is going to be equal to 2 times 64, which is 128. Okay, yeah, I'm running out of room here. Equals to 128. I think I got it. Does it fit? Yes, 128. Okay, y'all, 128. Again, I multiplied 2 times 64 to get 128. Now this would imply that b is equal to 33. Get this over here. Okay, so b is equal to 33 is the solution here. You know, and that's it. And again, y'all, my apologies. I should have chosen different letters here, like X and Y. Okay, so A would be behaving like this part right here, B squared minus X squared, and B would be behaving like X squared minus 31 squared. Okay, so hopefully the ambiguity there is not too much to overcome. And so when you sum this up, the X squareds cancel, which is nice, and you get that this is B squared. And I should have written, let's see. That this is maximum. Yeah, I should have made a different statement, but this is when the expression is maximum when you have equality. Okay, this is when this expression is as big as it can be, is when you have the equality between these two guys. All right, and so that probably warrants a comment. But anyway, b equals 33 is the solution. It could have been written slightly better, but hopefully I got the point across. Thank you for viewing.